Front-end Processor FEP Eurorack. FEP consists of CPU card, internal modem cards for answering and originating, status of modems in LED indications, 7-segment LED display, display card reset button, LCD display, keyboard. FEP functionality. Basic functionality of FEP is to receive the data from data logger network through network port and maintain data backup until sent to CMU by NMDL software. User interface with FEP consists of 5 basic modes: default display menu, communication status menu, port status menu, diagnosis and configuration menu, data backup menu, default display menu. After completion of power on diagnosis, FEP will be in default display menu. In this menu, the LCD display will be as shown. In this menu, database, it indicates the total number of records received by the FEP in the network from the data loggers. PC1, it indicates the total number of records transferred to CMU software through first PC port. PC2, it indicates the total number of records transferred to CMU software through second PC port. By pressing the star key, we can get main menu, which is having the options for remaining menus. For this, the LCD display will be as shown. Communication status menu. User can get this menu by pressing one key at main menu. LCD screen for this menu will be as shown. In this menu, user can see the communication status of FEP in 3 different manners. They are data logger-wise communication status, RTU-wise communication status, FEP port-wise communication status. Communication status data logger-wise. By pressing one key in the communication status menu, user can see the communication status of FEP in data logger-wise. It gives the following information. Total number of records are received by the FEP. Total number of duplicate packets are received by the FEP from a particular data logger. This information will be provided on LCD screen as shown. In this screen, DL070 indicates the data logger ID. S indicates total successful packets received by FEP from DLID 070. D indicates total duplicate packets received by FEP from DLID 070. If there is no data logger data available for FEP to display, then it will display the following message. Communication status RTU-wise. By pressing 2 key in the communication status menu, user can see the communication status of FEP in RTU-wise. It gives the following information. Total number of records are received by the FEP. Total number of duplicate packets are received by the FEP from a particular RTU. This information will be provided on LCD screen as shown. RTU 001 indicates the RTU ID. S indicates total successful packets received by FEP from DLID 001. D indicates total duplicate packets received by FEP from DLID 001. If there is no RTU's data available for FEP to display, then it will display the following message. Communication status port-wise. By pressing 3 key in the communication status menu, user can see the communication status of FEP in port-wise. It gives the following information. Total number of records are received by the FEP. Total number of failed packets received by the FEP. Total number of duplicate packets are received through FEP ports. This information will be provided on LCD screen as shown. P01 indicates FEP port number. S indicates total successful packets received by FEP through port 1. D indicates total duplicate packets received by FEP through port 1. F indicates total failed packets received by FEP through port 1. If there is no data received by FEP through any port of FEP, then it will display the following message: Ports Status Menu. This menu consists of the information regarding the all ports link status, and also there is a provision to reset the modems of FEP through keyboard. This menu will be displayed whenever 2 key is pressed at main menu. This menu is called as Port Status Menu. On LCD screen, this menu will be as shown. Identification of modem link status. Press key 1 for displaying the modem link status of all network ports and link status of PC ports. This information will be provided on LCD screen as shown. Modem reset through keyboard. Press key 2 in Port Status menu for getting the option of modem reset for all the network ports through keyboard. This menu will be displayed on LCD screen as shown. In this screen, total 8 keys are provided for resetting 8 network ports of the FEP. If we press key 1, then modem of first network port will be reset. By pressing key 1, the LCD screen will display the following message: Diagnosis and Configuration Menu. This menu consists of the information related to power on diagnosis results of the FEP and its port configuration and its own configuration. This menu can be displayed on LCD screen by pressing key 3 at main menu as shown. Power on diagnosis report. This option will give the information regarding the power on diagnosis results of the FEP. By pressing key 1 at Diagnosis and Configuration menu, we can see the power on diagnosis report. This report will be displayed as shown. Press hash key for viewing next diagnosis result. The screen appearance will be as shown. In the similar way, the remaining power on diagnosis for Dallas timer and all ports of communication ICs will be displayed on LCD screen by pressing hash key. Key 0 will have the significance to view the previous windows of this diagnosis results. FEP port configuration. This option will give the information regarding the port configuration of the FEP. By pressing key 2 at Diagnosis and Configuration menu, we can see the port configuration of FEP. This will be displayed as shown. In this screen, port 01, it indicates port number. Type modem, it indicates the type of communication. BR57.6, it indicates the baud rate of the port. VALCRC, it indicates the validation procedure for this port. By pressing hash key at this screen, we can see the port configuration for remaining ports of FEP one by one. Key 0 will have the significance to view the previous windows of this port configuration. FEP configuration. This option will give the information regarding the FEP configuration, device configuration, and other parameters related to the device. By pressing key 3 at Diagnosis and Configuration menu, we can see the FEP configuration. This will be displayed as shown. M indicates the present FEP mode. D01, S003, H03 indicates version information. F/W indicates firmware version. By pressing hash key, we can get the power on time of FEP. It will be displayed as shown. By pressing hash key in this screen, we can get the present FEP date. It will be displayed as shown. By pressing hash key in this screen, we can get the checksum value of the device. It will be displayed as shown. Data backup menu. This menu can be obtained by pressing key 4 at main menu. This menu gives the information related to the data backup in the equipment in which flash memory is used for data backup. In this menu, status of flash memory, number of clusters present in the flash memory, from which date the data is present, and the number of files present in the flash memory will be given. This will appear on the LCD screen as shown. By pressing key 1 in this screen, then we can get the health status of the flash memory, and it will be as shown. By pressing key 2 at data backup menu, then we can get the information related to the number of clusters. It is a data storage area in the flash memory chip present in the flash memory, and it will be displayed as shown. By pressing key 3 in data backup menu, then we can get the number of records stored in the flash memory chip, and it will be as shown. By pressing key 4 in data backup menu, then we can get the data available dates in the flash memory, and it will be as shown. By pressing key 5 in data backup menu, then we can get the data available in the flash memory, and it will be as shown. Movement of data from data logger to test room. Digital input 1 changes status as data logger A. A packet 1 is generated with temporary status and kept in main memory of data logger A. 2 copies of packet 1 are sent to buffers south and north of data logger A. Packet 1 reaches FEP through 3 paths. Path 1. Packet 1 from buffer south of data logger A is sent to buffer north of data logger D. Acknowledgement is sent by data logger D to data logger A. Packet 1 is removed from buffer south of data logger A. Packet 1 moves from north buffer to south buffer in data logger D and subsequently sent to FEP through path 1. Acknowledgement is sent by FEP to data logger D for packet 1. Packet 1 removed from buffer memory south of data logger D. Actually, all 3 copies of packet 1 travels in 3 directions simultaneously. Now, 3 copies of the same packet 1 are available in FEP memory. FEP removes 2 duplicate copies of packet 1 if all 3 are with a group of 100 sequential packets. Packet 1 is taken by CMU, that is Central Monitoring Unit, with the help of NMDL software. Acknowledgement is sent by CMU to FEP. Packet 1 is removed from FEP. Packet 1 is kept in a separate memory allocated for data logger A in sequence. In case duplicate packets are not removed by FEP because some of them reached late to FEP. Others are removed by NMDL software in CMU. Input requirements. To monitor the status of the relay, one potential free front or back contact of the relay is wired to data logger. To monitor the analog voltage is connected to the data logger. Digital inputs. One Euro rack equipped with all cards is capable of accommodating 5 12-digital inputs and scan up to 4096 inputs. To increase the digital inputs capacity, additional Euro racks are required. A housing rack can accommodate 3 Euro racks with the following capacities. Euro rack 1, 5 12-digit inputs. Euro rack 2, 32 analog plus 5 12-digit inputs. Euro rack 3, 1024 digital inputs. The digital inputs configuration can be set through the dip switch provided on the CPU card. Wires from relay contacts are terminated on an intermediate tag block. Wiring between the intermediate tag block and data logger is done by indoor single strand cable. Cable is terminated on digital tag block of the data logger. Each digital tag block can be terminated with 128 inputs. Each input on the tag block is numbered. Based on the number provided on the tag block, the user should connect the required input. Each digital tag block contains two 64-pin male connectors. Each 64-pin connector handles 64 digital inputs. These tag blocks are connected to the data logger motherboard by two ribbon cables each with 64 inputs capacity. Thus, a 512 capacity data logger has 8 ribbon cables. At the data logger's back panel, the 64-pin male Euro connectors are marked as DIGX, X range from 1 to 8. The connections should be made in such a way that the ribbon from the first 64 numbered inputs on the tag block should be connected to the DIG1 connector of the data logger. The next 64 inputs, that is 65 to 128, should be connected to the DIG2 connector. The next 64 inputs should be connected to the DIG3 connector, and so on. Thus, the last 64 inputs, that is from 449 to 512, should be connected to the DIG8 connector of the data logger. To increase the capacity of digital inputs beyond 512, additional digital motherboard is required, which will be mounted in the additional Euro rack. This additional rack has a provision for connecting up to additional 1024 digital inputs by additional 16 digital cards. However, for input configuration of additional 1024 inputs, that is 1 to 512, 513 to 1024, only 8 cards are needed. For providing 24-volt power supply to this digital expansion motherboard, a 4-pin male supply connector has been provided on its back panel. 24-volt supply to this additional rack is connected from the load terminals extended from the charger in the housing rack. Additional digital motherboard in additional Euro rack is connected to the main motherboard main Euro rack by ribbon cable. A 25-pin male connector labeled 513 to 1024 digital has been provided at the back panel of the main motherboard. 25-pin male connector is provided at the back panel of the digital expansion motherboard. To interface these two tracks, a suitable ribbon cable is used, which is having 25-pin female connectors at both ends. Similarly, for the inputs in the range 1025 to 1536, 1537 to 2048, 2049 to 2560, 2561 to 3072, 3073 to 3584, 3585 to 4096. A similar 25-pin male connector labeled 1025 to 1536 digital, 1537 to 2048 digital, 2049 to 2560 digital, 2561 to 3072 digital, 3073 to 3584 digital, 3585 to 4096 digital respectively has been provided at the back panel of the motherboard. To connect the digital inputs from the tag block to the data logger, a ribbon cable has been provided. Each ribbon cable will carry 64 inputs. Thus, 2 such ribbon cables will be needed to connect all the 128 inputs of the tag block to the data logger. This ribbon has a 64-pin female Euro connector at both the ends. Each tag block's ground terminal should be connected to the source negative terminal. Analog inputs. Data logger has a capacity to connect 96 analog channels. Each analog scanner unit will contain 4 types of cards. They are analog scanner card, analog motherboard, analog protection strip card, AC to DC converter box. In data logger, for scanning 16 channels, 1 set of analog cards, 1 with controller and 1 without controller is needed. For 32 analog channels, 2 sets of analog cards will be needed. The procedure to connect 32 analog inputs is as given below. Insert with controller cards into the analog motherboard at the slot labeled with controller. Insert without controller cards into the analog motherboard at the slot labeled without controller. For providing supply to these analog cards, 4-pin male connector has been provided at the back panel of the analog motherboard. Connect the 24-volt supply to the analog motherboard from the source load terminal through an appropriate cable having 4-pin female connector at one end and 2 wires for connecting positive and negative terminals of the source. Connect it to the source in such a way that the positive wire should be connected to the positive terminal and the ground wire should be connected to the negative terminal of the source. For communication between analog setup and the data logger main rack, a 9-pin male D connector has been provided at the back panel of the analog motherboard. The data concerned to 32 analog channels will be transferred through this single port. 6 similar 9-pin D connectors have been provided at the adapter PCB labeled Analog 1, Analog 2, Analog 3, Analog 4, Analog 5 and Analog 6. Each port will scan 16 inputs. To connect these 2 setups, use the suitable 9-pin current loop cable and connect it between the 9-pin connector at the analog motherboard and to any of the 6 connectors at the communication adapter PCB. Connecting analog inputs. To connect the analog channels from the external inputs, a PCB named Analog Protection Strip Card has been provided. To each such PCB, it is possible to connect up to 8 analog channels. Thus, to connect 32 analog signals, 4 such PCBs were required. On the strip PCB, the name of the channels which has to be connected is provided. Connect the analog voltages to the strip PCBs as per the names given on it. For the case of AC input, first connect channel output to the AC to DC converter unit, and then this DC output should be connected to the corresponding channel labeled on the stripped PCB. For DC voltages, connect it directly to the corresponding positions labeled on the strip PCB. To connect the strip PCB with the analog motherboard, a 64-pin male connector is provided on each analog protection strip card. To connect 32 analog channels from analog protection strip cards, 4 64-pin male Euro connectors are provided at the back panel of the analog motherboard. To connect the analog motherboard with the analog protection strip card, a ribbon having 64-pin female connectors at both the ends has to be used. Now, connect the first 8 channels from the concerned stripped PCB to the 64-pin Euro connector labeled with controller ANA1 on the back panel of analog motherboard through a ribbon as discussed above. Connect the second set of 8 channels from the concerned strip PCB to the 64-pin Euro connector labeled without controller ANA2. Connect the third set of 8 channels from the concerned stripped PCB to the 64-pin Euro connector labeled with controller ANA3. Finally, connect the fourth set of 8 channels from the concerned stripped PCB to the 64-pin Euro connector labeled without controller ANA4. User should connect proper voltages to the strip or converter box according to value marked on that the strips, and 24-volt power supply should be provided to analog scanning card in each unit. Card selection. A dip switch is available on the analog scanning card to assign an identification number to each unit. As each unit corresponds to 16 analog inputs, maximum of 6 units for 96 analog inputs can exist. Switches 1, 2 and 4 are used to identify these 6 units. Switches 3 and 5 should always be in off condition. Proper combination of switches for setting identification number is shown in this table. After connecting the analog channels, see the status of each channel using the keyboard option. By this option, user can easily identify whether all channels are connected properly or not. If any unit is not connected properly, then data logger will display an extra character F on the analog status screen. Digital input wiring. From relay to intermediate tag block. 16 bar 0.2 mm multi-strand wire for metal to carbon relays. 0.6 mm diameter single strand wire for metal to metal relays. From intermediate tag block to digital tag block of data logger wiring. 60 or 40 core by 50 pair 0.6 by 0.5 mm indoor cables. For digital tag block to motherboard, 7 by 0.13 mm 28 AWG 64 core flat ribbon cable is used. Analog input wiring. 16 by 0.2 multi-strand wire or 0.9 mm square wire with fuse protection for connecting from source to analog protection strip data logger. For connecting from analog protection strip data logger to analog scanner cards data logger, 7 by 0.13 mm 28 AWG 64 core flat ribbon cable is used. All relays required for tracing the operations through simulation diagram and fault alarms are to be monitored. We consider one contact of one of the repeaters of each type of relay need to be monitored. This may be followed for existing stations where data logger is already working. However, if complete circuit tracing is required, one contact of each relay shall be monitored. This may be followed for new installations. Point relay consist: switch or button relay, lock relay, operation command relay, detection relay, crank handle key in relay, crank handle lock relay, crank handle release relay, emergency operation button relay, point stick relay, siding point control relay. Signal relay consists: switch or button relay, control relay, lamp relay. Root relay consists: button relay, root freeness checking relay, root checking relay, root locking relay, root release relay, root or slot cancellation button relay, root or slot cancellation initiation relay, root cancellation timer relay, overlap locking relay, overlap cancellation relay, direction relays, track relay consist, track relay, track stick relay, axle counter relay consist, axle counter probing relay, axle counter preparatory reset relay, axle counter reset cooperation relay. LC gate relay consists switch or button relays, gate closed relay, gate locked relay, emergency gate release relay, miscellaneous relays, time element relays, power monitoring relay, point signal failure relay, SMR, siding control relay, siding switch or button relay, slot switch or button relay, slot control relay, king lever or switch relay, relay room open or closed, ELD earth leakage detection contacts, approach track relays, block circuits, SGE block, LCPR, SR, ZR, LSSDR, PTJ tokenless block, ASCR, TAR, all internal relays which have spare contact, FM diodo type, HSR, ASDR, Niels token block, TGTR, LSSDR, IPS, inverter 1 fail, inverter 2 fail, FRBC output fail, DC to DC converter fail, mains fail. Call S&T staff. Battery low, 50% deep discharge. IBH relay consist control relays, pass at on relays, stick relays, reset relays. Battery charger. Two 30-volt AC input to the battery charger of data logger should be protected with Class B and C surge protection device. AT supply or standby diesel generator supply also is to be extended to the battery charger of data logger. Battery charger earth terminal should be connected to data logger rack with 64-strand 31 SWG copper cable. Ensure that all terminals are tightened. Practically no voltage drop shall be observed between the battery and data logger power supply input terminal, since battery is provided within the data logger rack. Voltage limits at data logger terminals 24 volt to 28 volt DC. Switch off the charger when it is in float mode. After 15 minutes, measure the voltage. Practically no voltage drop shall be observed. Ensure that the earth resistance is less than 2 ohm. Separate charger and battery are provided when the capacity exceeds 2048. It is provided in the second equipment rack. IPS, Integrated Power Supply. If IPS is available, then power supply of data logger may be taken from IPS. When DC to DC converter is connected, ensure that the 24-volt DC supply wires connected between the DC to DC converter output terminals and the data logger terminals are not running parallel to other power supply wires. There shall not be any joints in the power cable. Separate DC to DC converter module shall be used exclusively for data logger. Voltage limits at DL terminals 24 volt to 28 volt DC. Rating of DC to DC converter shall be 5 ampere up to 1024 inputs, 10 ampere for 1025 to 2048 inputs, 15 ampere for 2049 to 4096 inputs. Types of wires used for various connections. Battery charger body to earth terminal 64 strands 31 SWG copper wire. Battery charger output terminal to DL power supply input, 28 strands 31 SWG copper wire. Battery charger to battery, 28 strands 31 SWG copper wire. Inter battery connection, 64 strands 31 SWG copper wire. Fault analysis system power supply requirement. 230 volt AC supply extended to the PC has class B and C protection. Power supply availability, DG set supply and AT supply where provided is also to be extended to the PC. UPS capacity may be decided based on power supply availability at the station to avoid abrupt shutdown of the system which may corrupt the software. The minimum power backup of UPS should be 6 hours. The same should be verified quarterly. The earth connectivity cables are to be connected with 10 square millimeter multi-strand copper cable for protecting the data logger, and it also mainly connected for data logger Euro rack to the frame, within the frame of the data logger. Data logger frame to earth terminal in the room. Ensure that the earth resistance is less than 2 ohm. Ensure that the quad cable where provided armor and screen are earthed. No separate protection is provided for power input cable as it is already derived from class B protection supply. Such protection is provided for communication lines by GDTs and varistors. To ensure galvanic isolation standard 1:1, transformer has to be provided before GDT for every pair of communication cable connected to the modem. How to operate data logger? First, switch on the power supply which is provided on the rear side of data logger unit and observe the LCD panel and 7-segment LED display on front view of the data logger. All the operations software can be performed by keypad and observing LCD panel. Specification of digital inputs. The logged digital signals specifies the status of digital inputs. Chattering signals. Status of digital inputs. The relay is having 2 states pickup or drop. User can get the relay status in 2 modes. Online mode, offline mode. In online mode, user can easily find out the current status of digital input signals in any one of the following way: through LCD display, through LED indication, by taking the print from printer. Digital input status through LCD display online mode. When the data logger is switched on, it will be in self-diagnosis mode for some time, and finally a default display screen shown will appear. Here TFD indicates the total packets sent from COM port 1, total failed packets received by COM port 1, and total pending packets to transmit from COM port 1 respectively on first row of LCD display. Similarly for COM port 2 in second row. The following procedure will give the present status of the digital input on the LCD screen. Press star key at default display menu. Then the following menu will be displayed and it is called as main menu. At main menu, press key 1 for selecting the data logger options. Now the following screen will be appeared on LCD screen. Now press the key 3 to select the DGT digital option. Then the following screen will appear on the LCD panel. By selecting the required category of digital input, the status of corresponding signals will be displayed on the LCD. All the options and the significance for viewing the digital input status are as follows. All will indicate the status of all digital inputs. TPR track proved relay will indicate the status of all the TPRs connected to the data logger. PNT points will indicate the status of all the points connected to the data logger. ROUT route relays will indicate the status of all route relays connected to the data logger. BTN button will indicate the status of all the button relays connected to the data logger. SLT slots will indicate the status of all the slot relays connected to the data logger. SIG signals will indicate the status of all the signals connected to the data logger. RLAY relay will indicate the status of all other inputs which are configured as relays. After entering into the required option, press the hash key to view the status of the next relay, or press 0 key to view the status of previous relay inputs. For example, when key 1 is pressed, the following screen will be displayed on LCD. In this screen, first row indicates the selected input number, date and time at which the signal status is changed, and on second row, signal name and its status will be displayed. Digital input status through LED indications online mode. Online status of digital inputs can be shown with the help of LED indications on the LED block display. In the front panel of the data logger, a block of 512, that is 32 into 16 LEDs are present, which is labeled as digital status. Each LED in the block will indicate the status of one digital input. If LED is glowing, then it indicates that the corresponding relay is in up state, and if the LED is in off state, then it indicates that particular relay is in down state. Status of particular digital input on LED block display. Topmost left corner LED will indicate the status of first digital input, and the next to the right will indicate the status of the second input, and the next input to the right will indicate the status of the third input, and so on. The last LED on the rightmost of the first row will indicate the status of 32nd input. The first LED in the second row will indicate the status of the 33rd input status, and so on. The last LED on the rightmost of the last row will indicate the status of 512th input. Status of particular digital input on LED block display from 513th input. A block of 512 LEDs is called a page. Thus, a page will indicate a status of 512 inputs. If the numbers of inputs are more than 512, then the remaining input status can be viewed in the next pages. Maximum of 8 pages is provided to view the 4096 digital input status. To view the status of next page, in main menu, press key 1 for selecting the data logger options. Now the following screen will appear on the LCD. Select the page option by pressing the key 2. Then the following screen will appear on the screen. Page number XX is for representing present page number. 0 is for previous page display. Hash is for next page display. Star is for default display menu. By entering the page number in the page number option, user can directly go to the required page. For viewing the required digital input status on LED block display, select the corresponding page number by pressing the required keys. Default display of page number will be 00. The digital input configurations and the page numbers concerned to that configurations are given in this table. After entering the required page number, if it is a valid page number, then the following screen will appear on the LCD panel. By pressing hash key, the LED display will change accordingly to the status of digital inputs selected. If page number entered is invalid, the following screen will be displayed. For main menu, press star key. By pressing the hash key, it will go back to the previous screen. Digital input status through printer online mode. User can get the online information of the change in digital input status by using the printer option. Only the changed input status would be recorded or printed. If the digital input status is not changing, then its status will not be printed. To get the printout in online mode, follow the instructions. In main menu, press key 1 for selecting the data logger options. Now the following screen will appear on the LCD. For selecting print option, press the key 6. Then LCD displays the following screen. This is called printer menu. Press 0 key to change it to the online mode, then the following screen will appear. Now printer will start printing the latest changes in the status of the digital inputs and analog inputs provided printer is ready to print. Digital input status through printer offline mode. To get the digital inputs status and analog voltages in offline mode, there is only one option, and that is taking printouts. The offline printing is well organized. User can even print a single input status or faults of one type, digital or analog. All the events for printing are mainly divided into two categories, such as digital, analog. In digital, again it is divided into two types. They are digital input relay status and digital faults. All the digital inputs are divided into 7 types: tracks, points, routes, buttons, slots, signals, general relays. If the time interval entered for offline printing is valid, then the following screen will appear. Key 1 for selecting digital, analog events and faults printing. Key 2 for selecting digital events printing. Key 3 for selecting analog events printing. For printing the digital inputs, press key 2, then the following screen will appear. Key 1 for selecting both digital input status and faults printing. Key 2 for selecting digital inputs status printing. Key 3 for selecting digital faults printing. For printing the digital inputs, press key 2. Then the following screen will be appeared. For selecting the other group input for printing, use key hash or 0. For example, if the user wants to print the status of a track input, then the user has to press key 2. Now the display should be as follows. Key 1 for selecting all track inputs. Key 2 for selecting only selected track inputs. If we press key 2 for selecting few track inputs, then the following screen will be appeared. Here in first row, signal name and its selectivity, that is, whether it is already selected or not, will be displayed. Press key 1 for selecting the input if the input is not selected earlier, or for deselecting if it is already selected. Keys hash and 0 are for next and previous digital inputs viewing in this type. Press key 9 for end of selection of inputs for printing. Now the display on the screen will be as shown. Key 1 for viewing the selecting inputs for printing. Key 2 for printing the selecting inputs. Key 3 for editing the selecting inputs for printing. Key star to go to main menu. Press key 2 for printing the selected inputs. Now the screen will be as shown. Key hash for stop printing. Key star to go to main menu. Make sure that the printer is ready to print while going for offline printing. If the printer is not ready, then the following message will be displayed on the screen, and after some time, main display will be displayed. Same procedure has to be followed for printing the digital faults, analog channel voltages and faults of analog channels. To identify chattering inputs, online mode. If any input status changes more than or equal to 8 times in 4 seconds, then that input will be declared as chattering input. By using corresponding options in data logger, user can find out the loose contacts and defect relays. To view the chattering inputs online, follow the given steps. When the screen is in main display on LCD, then press hash button in the keyboard at default display menu, then following screen will appear on the LCD. Press the key 4 to select the CTR chattering option. If any of the inputs are chattering, then following screen will appear on the LCD. 0318 represents inputs numbers. A 2 HHECR represents input name. If no inputs are chattering, LCD screen will show the following message. Analog channels. Specification of analog channels. The analog voltage variations can be logged through data logger. If the variations in analog voltages are beyond the tolerance limits, then its values will be recorded and will be updated in the concerned fields. User can get this information in 2 modes: online mode, offline mode. In online mode, analog channel status can be known in 2 ways: through LCD, printout. Analog channel status through LCD. User can view the online status of the different analog channels by following the given procedure. In main menu, press key 1 for selecting the data logger options. Now the following screen will appear on the LCD. Now press 4 to select ANG analog option. Following screen will appear. In this screen, first row contains channel number and the date and time at which the channel was scanned. On second row, the channel name and the actual voltage on the channel will be displayed. Press hash key for knowing the voltage of next analog channel. If analog scanning cards are not connected properly or analog communication fail between CPU module to analog scanning module, then it will show following screen. Here, F indicates that the corresponding channels are in out of link or not connected. Press star key to go to default display menu. Analog channel status through printout. Follow the similar procedure mentioned in digital module to take the printout for online status and user selected time intervals. To know data logger surrounding temperature. Data logger will also log its surrounding temperature. It can be seen on the LCD display of the data logger. To view its status in main menu, press key 1 for selecting the data logger options. Now the following screen will appear on the LCD. Press the key 7 for selecting the TMP temperature option. Then the following screen will be displayed on the LCD. In this screen, the value 30 degrees Celsius is the surrounding temperature value logged by the data logger. By pressing the key star, the screen will return to the default display menu.